And the name of our next quadrilateral that we're going to study is called the parallelogram. So we're going to learn about the properties first of a parallelogram, and there are 5. So 5 properties that we're going to study, a little bit different than the trapezoid that we just talked about. So 5 properties. The first one is going to be, let's draw it first. So the biggest difference between the parallelogram and the trapezoid, if you remember the trapezoid, I'm just going to draw this guy up here. The trapezoid had just this one set of parallel sides. The other set here was not parallel because they'll eventually intersect. So in the parallelogram, instead of having one set, it has 2 sides of parallel sides. So 2 sets of parallel sides. So if you remember, what they're going to do is they will make these little arrows, and these arrows indicate that these 2 are going to be parallel, and then the other set, these 2 over here, are going to be parallel, and they'll put 2 arrows. So the arrows means parallel, not that they're equal. Okay, so the next part is we're going to continue with the sides. So I'm going to draw another parallelogram here, and we're going to name this parallelogram quad. Alright, so the second property is also about the sides. So not only are they parallel, but the opposite sides are equal. So opposite sides are congruent. So that means that QU and DA are equal to each other, and the other side would also be equal to each other. So QD would be equal to UA. And so remember, we would mark those with 2 slashes and 1 slash. Alright, so not only are the opposite sides congruent, but let's take a look at the angles. So let's just throw some numbers on here. So let's say that Q is 100 degrees. Okay, this is different from the trapezoid, because remember in the trapezoid the base angles were equal. So it's not true this time, because you can definitely see that this angle Q is obtuse and angle U is acute. So it's not that they're going to be equal to each other. So what's going to happen is that the opposite angles are going to be equal. So that would be the third property, is that opposite angles are congruent. So you can mark those with 2 or a swoop if you want, and then the other 2 are also going to be equal, so you could mark these with 2 swoops. So what do you think that these other angles are going to be that we don't have listed here? So for example, what is U and D? Well, it's the same idea of the trapezoid, except for the opposites are equal, and this right here, if you notice, are consecutive or same side interiors. So if you look at their positioning, see how they're in the inside of the parallelogram? Well, that means that the consecutive or same side are going to be equal to 180. So consecutive angles, the ones that are right next to each other, you can also name them as same side. They are going to equal 180. So that means that if you subtract from 180, these other angles are going to be 80 and 80. So let's do another quick example just in case. Let's draw one down here at the bottom, and I'll have it slant the other way just so you can get the hang of this. So let's throw a number in here. Let's say that this side, this angle is going to be 45. So if I tell you this is 45, you should be able to fill in all the rest of the angles. And let's go ahead and name this just side. So quadrilateral side. So if S is 45 degrees, according to the rules, the opposite is going to be equal to 45 as well. So S and D are opposite angles. So that means angle D is also going to be 45 degrees. And then, according to the rule, opposites are equal, but then same sides are going to be equal to 180. So that means I and D are going to be equal to 180 because they're on the same side of the quadrilateral. So I would go 180 minus 45, and I would get 135. So that means that this angle, I, is 135, and then so would be angle E, because opposites are equal, or, same thing, these are same side consecutive, these are same side consecutive, S and E. So now again, if you wanted to add them all together, 45 plus 135 plus 45 plus 135 will give you 360. But remember that the same side is going to equal 180. Okay, the last property then, property number 5, has to do with the diagonals. So now what I'm going to do is draw a quadrilateral or a parallelogram that has diagonals in it. And I'm going to still name it quad as we worked with before. And then I'm going to name the inside intersection as X. So if you remember in a trapezoid, again I'm just going to draw this, you don't have to draw this on your paper, but in a trapezoid, the diagonals were equal to each other. And that made sense because they definitely look like they're the same length. Well, if you look at these diagonals, the diagonals in here are going to be named as QA, so that's one diagonal. And then the other diagonal is going to be DU. Now you can clearly tell that DU is longer than QA. So they're not equal to each other, but they do bisect each other. So the fifth property is that the diagonals bisect. And so what that means is that they cut each other in half. So if DU is cut in half, X is going to be the midpoint. So that would mean that from D to X is the same measurement as from X to U. So if you want to write that down, dx would be congruent to xu because the diagonals are going to cut each other in half. And then the other pair would be qx would be equal to xa. Okay, so those are the 5 properties. There's 2 more examples I want to show you of some different things that you will see for properties, and I want to make sure that you're not confused when you see them on your classwork. So a couple other examples. Let's look at one here. Now keep in mind that diagonals are important, and also that you may have some, to think of some old rules like triangles are 180, maybe alternate interior, etc. So I'm going to draw 2 different parallelograms. So this one has one diagonal in it, and this one is going to have both diagonals in it. So each create a different set of problems that you might have. So in the first example, what I'll do is I'm going to put in, I'm only going to give you 110 and 20, and we're going to fill in the rest. So I'm going to name them just letters like X, Y, W, and we'll call this one A. So with 110 and 20, you should be able to fill in the rest of these angles just by knowing opposites are equal and alternate interior. So since opposites are equal, what would be opposite of 110? The Y. So angle Y is going to equal 110. Alright, so now let's look at angle 20. How can I use angle 20 to help me? Well, angle X over here is alternate interior. It makes that Z. So that means that angle X is also going to be 20. Now how are we going to get A and W? Well, this here is equal to 180 degrees. So I can do 110 plus 20, and that gives me 130, and then subtract that from 180, and I'll end up having 50 left as the triangle. And so if A is 50, then W is also going to be 50 because they are alternate interiors. So just some things to think about when you're solving. Alright, how about number 2? So I'm going to throw in here a 30 degrees down here in this corner. I'm going to put 100 in the middle. And then we are going to try to figure out angle X, angle Y, and this angle W. So let's start with angle Y. That one's the easiest. You can just look at that and you should be able to tell me how much angle Y is. Because angle Y is alternate interior to 30. So angle Y equals 30. Next then is angle X. So angle X, since you know that y is 30, you can do the triangle rule. So 100 plus 30 gives me 130, and so I would have 50 degrees left in order to get 180. So that's going to be 50. And then last but not least, the w. So w right here makes a linear pair with the 100, so angle w is going to equal 80. Okay, last thing on the list is the area formula. So the area of a parallelogram is A equals base times height. Now how this happens is, watch this, a parallelogram is actually two triangles put together. Remember, a triangle is 1/2 base times height. So if you go 1/2 base times height plus 1/2 base times height, adding the two areas together, if you add these coefficients, that will give you 1 base times height. What? So that's how they end up with the area of a parallelogram. So just to do a quick example here, what you'll see in a parallelogram is you'll need to have one of the bases. So the base, let's say this here, was 8, and then they gave you that the height was 6. They may throw some other numbers like a side over here. This 9 has nothing to do with the problem. You only want to look at the 8 and the 6. So you would just go area equals 8 times 6, and the area is 48. Simple as that. So when you come to class, you are going to be ready to go.